Hey guys, welcome back to the old mill shed. So I started this video about 8 weeks ago. Before this was actually running, you can see it's actually running now. So you're going to notice some continuity issues, wearing different clothes, leaves changed, weather. Some of these parts of this video were shot on some of my older equipment. There's been some microphone upgrades. Just about everything has changed as far as what I use to make videos from the start of this video to now. So please just disregard that. I'm trying to get better and better equipment the more and more I go, so some of these videos you're going to notice that some things start off kind of grainy, and then by the end of the video everything looks a little bit different. That's why I'm constantly upgrading as I go along. So this is what we're working on today here at the back of the stove. You can see, probably hear it a little bit, especially with the microphone being right there. This tube, it comes through the back wall of the water jacket, has never really sealed right. We brazed it when we built it, and for some reason it just didn't take. Everything else seemed to work good. So what I have done, I have gotten a 1/4-inch steel plate, bored a hole through it, and put another piece of pipe in it. We're going to braze that in, and then we're going to weld the whole assembly here. But I'm going to cut through the water jacket here and grind everything smooth, and then take my little wire welder, weld it back up. Now this is empty. I drained this yesterday. It's been draining all night, and I do have the hot water pipe unhooked, and of course the cold water is right here where it comes in. We're going to scrape all that and paint that as well. And we'll go over how all of this works later on in the build part, or it might be earlier on by the time it gets edited, but we'll figure it out. So I'm going to drill 4 holes, and then I'm going to take my grinder and we're going to cut that out. Now, one reason that I drill holes when I do this instead of just going in with the grinder and cutting out is, if you drill a hole, you got a little bit of a radius there, and a radius will prevent a stress fracture from starting. I don't think it's going to be enough here to really do that, but why take the chance? I mean, it's just 4 holes, right? Okay guys, so here we are after I cut this out. I had forgotten, this is supposed to be 8-inch thick steel, and when we had built Dad's stove, we had right much 1/4-inch steel left over, and we had used some of it on the back of this stove, which is fine. I mean, there's literally nobody policing this. You can see here is the tube, the output part of the tube that wraps around on top of the firebox. And we're going to take some pictures. I'm going to take a flashlight and shine back up there when I get all this off. You can kind of see how it lays on top of the firebox. Now, you're going to see a lot of brown granular stuff in here. I thought it was rust at first, but it's actually sediment. When we first built this house, after we had the well frack, we was getting a lot of sediment. We ended up putting a filtration system on the house to solve that. But a lot of the sediment, I guess it already made it into the stove, and it already kind of coated everything. And there is a little bit of surface rust. I have put a gallon of rust preventative in every year. I may want to bump that up to 2. Okay, I'm going to try to hold this steady, but there is the pipe, the tube that goes on top of the firebox. Now, what you're seeing out there, that is rust. I have definitely got to put some more anti-rust preventative in this a year. 1 gallon's not enough. Let's see here.
kind of tight quarters. But that's how your domestic water heater on this works.
Well, you know what they say. A grinder and paint makes me the welder I ain't. But I think that'll work. So about halfway through my welding, maybe a little less, I was using a carbon dioxide argon cover and the tank ran out. So I had to switch the welder over to flux core, which works, but I don't like it as well. And I was concerned I might have some like little pinholes in there or something. Nothing's under pressure, so I might be okay. But I'm going to mix up some PC7. Now this is a 2-part epoxy. Now I bought this myself for full price. I'm not being sponsored. And the great stuff about this is, or great thing about this stuff I should say, is it doesn't have to be mixed up exactly 1-to-1. And it's also good and thick, so it kind of stays in place when you're working with it. It is kind of hard to mix up, but that's about the only downside I can find with it. Let's get all this off the screwdriver here. And I have tried mixing this stuff up with a stick, bolt, whatever. I'm going to be honest with you, old flathead screwdriver works the best. Just clean it up when you're done, no problem. You see how thick this stuff is. I mean, you really got to work to get it out. It's sticky, it's gooey. And you have about an hour to work with it after you mix it. And then it takes 24 hours to harden, or at least, get hard enough that you can go ahead and use it. Use what you was going to use the repair, I should say. It takes about 24 hours. I think full cure is like 48 hours, but this stuff will cure underwater. It cures from the inside out. I'm not so much worried about that upper bead, because I was actually done with the cover gas. I'm more concerned about from here down. That's where I was having to use all the flux core. You can see where the welding changed as opposed to over here. This stuff is, I don't know how hot you can get it. We've had to use this on my dad's stove to make emergency repairs during the winter, and it worked. And in fact, it worked so much that until that stove was taken out of service, that continued to be the repair. We didn't go back and fix it after that. And the leak that it repaired ran for like 7 years, 6-7 years before we went back and built the other stove, the one that's like this one. But with the water jacket only getting up to 170 degrees, so it doesn't get as hot back here as one would normally think. Okay, we're going to let that sit up for 24 hours, and then we'll come back and paint over it. So we're back into November now, finally been able to get back out here. It's been a couple weeks since I last worked on this video. When I left last time, I had a piece of brass pipe in here, and I had just welded this on and sealed it up. Well, that brass pipe, I don't know if I got it too hot when I was brazing it, or that's all they could be. I must have got the pipe too hot and made it too thin when I was brazing it in, because after I threw pressure to it 3 or 4 times, it blew out inside of the stove and was dumping water into the water jacket. So I had to cut all of this back out. I redid it with a piece of steel pipe. And I just put some PEX fittings on here just to get it out and turn it down so that I could hook the braided hose up to it. And I also replaced this as well. The other one had gotten some corrosion right along in here. It was starting to drip a little bit. Didn't really want that. So I've tested everything else. It works. No leaks anywhere. I did drain it back out. There's one little drip I had that I wanted to put some more sealant on it. And then I tested it again. And I just wanted to drain it one more time just to make sure that nothing else was going to blow out as I was getting ready to fill it up for the last time. We're going to cut our grates here for the stove. Now each one has to be 22 5/8 inches long. Normally I will buy a 21-foot stick of Schedule 40 2-inch tubing, which I had done this time, but once I got it home I had another repair come up and I had to use it for that. And so instead of going back and ordering it, had to drive all the way down to Oddfellows Road to get it. Lowe's had these 10-foot sticks, but they're threaded on each end. And it was only like $15 more. And it was already cut 10-foot length, so I didn't have to take the trailer to go get it. Fit in the back of the truck, no problem. But each stick is 120 inches long. I don't want to leave the threaded ends on because that's tapered down. It's not going to be as thick and it could rust out faster and cause the grate to drop. So we've got 120 inches and we're going to divide that by 22.625. And that gives us 5.3 pieces per stick, which work. We need 10 pieces, 5 per stick. And so 0.3 times 22.625 means that we can cut about 6 3/4 inches off the total length of this pipe to get rid of the threads, and so we'll have a full width or full diameter pipe across our supports. Now it's only about 1.5 inches on each side, so we're good. So what we're going to do is we'll cut the threads off about 1.5 inches. Now we'll cut 5 out, and then I'll do the same on the other pipe. Now one thing about this saw that I really like better than the old saw I had is I can take a 1x6 or 2x6 and screw like a 2x4 in on each side of it to hold it upright, and it will support a piece of metal and it'll be level across the cutting platform here. So that's one advantage over this saw as the other saw. The other saw was 4 1/4 inches tall. So you couldn't use a 2x4 because it was 3.5 inches tall. And a 2x6 is 5.5 inches tall. So I always had to rip a board down or just make something to keep on hand all the time in order to have that piece of metal sit level every time I wanted to use it. So I'm going to pop out all the pieces and then we will I'll rejoin you as it's done, and then we'll put everything into the stove. And there we go, we got a nice new set of grates. Now the 21-foot stick of 2-inch Schedule 40 was $158, and going to Lowe's to get this 2 10-foot sticks of Schedule 40 ended up being, I think it was like $173, so it was a little bit more expensive, but I didn't have to drag a 16-foot trailer all the way to Lynchburg, and I didn't have to take off early from work to get down there while they were open. I was actually able to go after work one day. Alright, so while we're back here, I'm going to explain to you how this thing works from back here at the stove, and then we'll go through it. I'll draw it out inside. We'll combine the two so you can see what it does in the drawing and then see it out here. So coming up out of the ground, what I have buried to the house, we have 4 lines. We have a domestic supply. That's this one right here. This little horizontal one here. We have domestic hot water return. This is what goes in and bypasses the hot water heater and will come out of your faucets. We have our hot water, this pipe right here, that's a 1-inch pipe. That's hot water that goes into the radiant flooring. And that's the only place that water goes, is to the radiant flooring and then back through the radiant flooring return. Let me adjust this down here so you can see that. The radiant flooring return is this pipe right here, kind of hiding behind this. And then you can see it where it goes into the water jacket down low. Along with those 4 pipes, we have 2 wires. Now the first wire is this one, and it is labeled constant feed air pump. The second wire is this one, and it goes straight to the pump. This wire is controlled by the relay, which is controlled by the thermostat inside the house. We will see the controls for this in there. This one comes directly off the breaker, and it's very important this one is constantly hot. Off of this, I have a 110 outlet to use for repairs. Like if I'm out here in the middle of the night, I can plug a light up, or like when I was doing that, I was able to plug my little 110 welder, my grinder, anything that I need. It's just here for service purposes, and it is 12 gauge wire, so 20 amps, rated for 20 amps. Off of your constant feed, you have the Aquastat. Let me turn this up here. Okay. Off the constant feed, you have the Aquastat. When that is turned on, it will constantly monitor the temperature inside of here. When this reaches 170 degrees, and I just put my fingers all up in that PC7, nasty. When the Aquastat closes the circuit, when it falls below 170 degrees, it does 2 things. First thing it does is it activates the solenoid to pick the air shutter open and allow air to come in through the blower motor. It sends a signal up this wire. It sends a signal up this wire to a switch that is on the side. Then that switch comes back down to the blower motor, and the reason that switch is there, so if I'm putting wood into the stove and it's below 170 degrees, it's going to blow all that smoke back out on me, and I'm trying to see how to put the wood in and smoke's coming out and getting in my face and everything. I can turn that switch off, put the wood in the stove, close the door back, and then flip it back on, and it goes back to normal operation. Another thing I can do is if this blower motor goes bad, I can turn that switch off. It de-energizes the motor, which I can also unplug down here, swap the motor out real quick, and I'll still have current running to this, so I can hook a light up and see what I'm doing. Put the new motor on, plug it back in, flip a switch, and I'm good to go. Another thing I can do is if the solenoid goes bad, I can turn the switch off, I can unplug my wires off the solenoid, replace my solenoid, hook it back up, flip the switch back on, and I'm good to go. And there's also a secondary fail-safe. I don't have to worry about somebody turning a breaker on inside the house while I'm out here working on this thing and electrocuting me. I have a second switch out here. No matter what they do in the house, the current electricity is not going to reach me out here working on the stove. So all that clear as mud? Yeah, we'll draw it out and it'll make more sense to you once we get inside the house.
Here's the schematic for the electrical systems on the outdoor stove. So what we have here is we have the two circuit breakers, one for the blower circuit, one for the circulation pump circuit, which also includes the thermostat. We'll start with the blower circuit. It goes down to the aquastat, and the convenience receptacle is hooked to the constant feed uninterrupted, as is the aquastat. The only way to kill power to both of these is to trip the breaker. Coming out of the aquastat, it goes into the blower override switch. Now, earlier I said that the damper actuator was connected straight out of the aquastat. I misspoke. The blower override switch protects both the damper actuator and the blower motor. So if the temperature is below 170, this switch will close. If this switch is closed, then the blower motor will turn on and the damper actuator, the little solenoid, will open the flap onto the blower motor and it will feed air into the fire. Once the temperature reaches 170 degrees, this switch will open and the blower motor will cease to turn and the damper actuator will close back off to prevent air from getting into the firebox. On the circulation pump side, you have 110 or 120 volt feed going into the relay. The relay will take that and it will have 120 volt feed going to the circulation pump. And it will have 24 volt feed going to the thermostat. And the thermostat is controlled by three things. We have a slab sensor that detects the temperature of the floor. We have an outdoor sensor that obviously detects the temperature outside. And then we have the indoor temperature sensor, which is in the thermostat itself. The thermostat will take all of these inputs and determine when to send a signal back to the relay to close the contacts and turn the circulation pump on to circulate 170-degree water through the PEX tubes in the floor of the house.
So this is the relay box that I use to power the radiant floor. The power from the load center comes in here. This goes out back to the pump on the back of the stove. This feeds the thermostat out in the hallway. And I left myself some notes as to which wires go to which sensor. That's more so for the thermostat out in the hallway than it is this. So this is how it is wired up. So our grounds all go together. We have an N and H, which is bridged over to 3. We have 2 4s, 2 6s, and a 5. And then you have an R, a W, and a T. The blue supplies power to the thermostat. The white, the one in the center, is your common, obviously. And the red wire comes from the thermostat back to the relay. And that's what tells it to turn on and off. Okay, here we go. October 3rd. Now, it was still pretty hot October 3rd. November 3rd, we're going to finally do what we've all been waiting for. We're going to finally fire this thing up after all of its maintenance and everything. And I do have to keep this camera back away from it a little ways because, I don't want to set my equipment on fire.
all I'll do is I'll open my draft door, my ash door. Turn the fan on. Let's give that a minute to start a draft. Okay guys, we're 40 minutes in. When I first started recording this part of the video, it was 10 minutes ago. So like every take I make, I'm having to add a couple degrees because it's climbing about 1 degree Fahrenheit per minute. And we're at 90. We're at 91 now. So I've thrown in 7 or 8 sticks, you know, about that big around, of hardwood, 3 foot long, maple. I think 1 or 2 were white oak. They've been drying all year. And I keep them down here just for this. So I'll start off with the pine, then I'll throw the hardwood in. Get that good thick bed of coals going. I still have the ash door cracked open about 1 inch with the fan going, so it's just sucking massive amounts of air in. And it is smoking a little bit. That happens when we first start it up. When you are normally running this, the air coming out of the chimney is mostly clear. Now you throw some wood in there, it'll smoke a little bit right at first, especially if you forgot to put the tarp over the wood and it rained that night, and the outside of the wood's got a little moisture in it, then it's putting out a lot of white smoke, which is actually steam. It's not hurting anything. And I would dare say even the amount of smoke that this is putting out now, it's not going to hurt anything. We've been burning wood for thousands of years, and the polar bears are still here. We are already at 170 degrees. I was not expecting it to get here this fast. I'll reposition the camera, let you see up inside of the stove, and the reading on the thermostat, so you know I'm not lying to you. But it's just idling now. You can hear the fans not running. Most of the smoke you're seeing there, I just threw some more wood in, 3 or 4 pieces, and that's just the steam cooking off of, because we did have some rain here this past week, and the outside bark was a little wet. The inside part of the wood's still dry. It's not going to hurt anything. And these things, it actually helps if the wood, at least on this one, if the wood's a little green, lets the stove kind of cook it out, keeps it from burning too fast, and your wood charge will actually last a little longer. Okay, you really can't see up in there much. You see a little bit of the wood charge. It's just sitting there smoldering at this point. That's about all it's going to do. It's just going to sit there and smolder, and when the temperature of the water drops down, it'll throw a little bit of air to it. The flames will flare up. It'll get the water temperature back up to 170. It usually kicks on about 165, cuts back off at 170. And now that it's pushed all the water out of it, I'm not going to put the rust inhibitor into it yet because the floor hasn't been turned on, and that pump that puts the water through the floor is what's going to mix that into the water. Okay, so here's my load center in where I keep the water heater. So to turn this thing over from using the hot water heater to the outdoor stove, this first thing we do, I get the blower motor on to the stove. The circ pump, a circulation pump, that's for the floor. We're not turning that on yet. Turn the water heater off. I'm going to come over here. Now this pipe here comes up from my cold water manifold. And then it heads over cold water input.
Hot water comes out of the hot water heater, and it's connected up here to this pipe that goes down to my hot water manifold. Okay, I'm sorry if this is going to be shaky, but this comes in from the outdoor stove, goes back into the wall, and there is a pipe in here that goes up and over into the bottom of this. So what this does is I can turn this off, turn that on, and the hot water flows from the stove up through the pipe and back down to my hot water manifold. And then I turn both of these off to completely isolate my hot water heater, and I can do maintenance on this while I'm running off of the stove. So first thing we're going to do, I'm going to turn off the cold water, turn off the hot water heater to the hot water manifold, and turn on the stove. So stove is on, hot water heater access is off, and we're now on the outdoor stove for a hot water. Okay guys, that's the video. It's not a whole lot to these things. Most people just overthink it. So I hope you enjoyed it. If you did, please hit that thumbs up, like and subscribe, and hit that notification bell. It helps the algorithm a lot. We'll see you here next time under the shed.